I think he has told that a particular point. Yeah. So we'll again once again see that particular blocking and non-blocking. There was a little mistake in that particular point when we were discussing some example there. We will now rectify that, and with some practical examples also we will now see. Okay. I think my screen is also visible, right?
Yes, sir.
Yeah. 1 minute. Okay. No issue. Errors happen. Okay. So we'll start with this particular blocking and non-blocking assignments. So coming to this blocking assignments will block the flow of execution. That is one by one in a sequential manner. The blocking assignments will not will be executed. So basically, in the case of blocking assignments, executes in the order written within a procedural block. Like let's say, suppose if we use this particular blocking assignments, then it will this particular blocking assignment will execute sequentially. That is, after this a is equal to 1 assignment is happened, then only it is going to execute b is equal to a, then it is going to execute c is equal to b plus 1. So this is about blocking assignment. And one more thing, this blocking assignment, if you are using any blocking assignment, the updation is happening immediately at the same time step. That is, if we have written a is equal to 1, then the right hand side value is immediately updating on the left hand side value. Okay. So this is about the blocking assignment, and until this particular assignment is happening, a is equal to 1 is happening, it is not going to further execution. That is, it is not going to b is equal to a. Okay, is it clear for everyone?
Yes, sir.
Yes. Now coming to concurrent assignments or non-blocking assignments, coming to this non-blocking assignments are not going to wait for the completion of execution. That is, if we have written a non-blocking of 1 and b non-blocking of a, like this if we have written, so if this particular assignment is not completed also, it is the compiler is going to execute this second assignment. That is, everything is going to happen parallelly. Okay. And one more thing what we have seen, the right hand side value is going to be stored inside a temporary register internally, and this particular value is going to update it on the left hand side at the end of the current simulation time. Okay, when we were discussing this Verilog event scheduler, that we will see where this non-blocking execution is happening. Okay, so what is happening actually, this RHS side is going to be stored on a temporary register, and this particular value is going to be updated on the left hand side. Okay, so this is what it is happening in the non-blocking assignment. Is it clear for everyone? Yes. Now coming to this timing controls, we have seen that there are two types of timing controls. One is inter assignment delay, and another is intra assignment delay. One is inter assignment delay and the second one is intra assignment delay. Okay, so coming to this inter assignment delay, the delay value is specified on the left hand side. Okay, the delay value is specified on the left hand side, whereas in the case of intra assignment delay, the delay value is specified on the right hand side. The delay value is specified on the right hand side. This is nothing but our intra assignment delay. This is nothing but our intra assignment delay. Let's say suppose if we have a is equal to hash 5 1 and hash 10 b is equal to 1, then what is happening in the case of inter assignment delay, this particular execution is happening after 10 time units. After 10 time units, this entire execution is happening after 10 time units. Okay, and when in the case of intra assignment delay, this particular RHS to LHS execution is happening after 5 time units. It is happening after 5 time units. And in the case of inter assignment delay, this particular whole execution is happening after 10 time units. Is it clear for everyone, the inter and intra assignment delay? Is it clear?
Sir, one question here.
Yes.
So, in the first expression,
Hmm.
first statement, if we have after hash 5, if we have some expression,
Mm.
suppose like any addition express addition, yeah, some operations are happening, so they will happen at the zero time, and then after 5 time units then the assignment will take place. Is that
Yes.
will happen?
Yes. Okay.
Okay. Yeah.
Now, 1 minute. Now, so we have seen one example using this inter and intra segment delays. Now let us once again see that example. So within an initial Boolean block, A is equal to 0, hash 5, B is equal to 1, hash 10, C is equal to 2, and hash 15, D is equal to 3. Okay, and so after how many time units this D is equal to 3 will be happening? So at after how many time units this T is after how many time units D is equal to 3 will be happening? Yes. Others? Yes. So is it clear, right? So after 30 time units, my D will be equal to 3. So after 30 time units, my D will be equal to 3. Since I am using a blocking assignment, it is going to block. And in the case of inter-assignment delay, now we will see one more example and I will clarify it. Now let's say if we are using a non-blocking assignment, initial begin, same example we will take A non-blocking of 0, hash 5, B non-blocking of 1, and hash 10, C non-blocking of 2, and hash 15, D is equal to 3. And so here also after T is equal to 30 time units, my D will be equal to 3. Okay, so this is a small modification I want to make. So when you are compiling this, when you are using your tool and when you are typing this particular example, then after T is equal to 30 time units, you will get the value D that is equal to 3. That means when you are using this inter assignment delay, when you are using this inter assignment delay, it is going to block the further execution. That is here what happens, you are using your inter assignment delay hash 5, so it will block the further execution, whether it may be blocking or whether it may be non-blocking. This inter assignment delay is going to block your further execution. That is, this second step will wait up to 5 time units, and after 5 time units only this particular execution will start. That is, after 15 time units my C will be equal to 2, and after 30 time units my D will be equal to 3. So whether it may be blocking or non-blocking, and if you are using your inter-assignment delay, it is going to block. Okay, so this is a modification I wanted to make. Is it clear for everyone?
Yes, sir.
Yes. Yes. So like this, if you get any doubts or anything regarding this particular blocking or non-blocking, you can just simply open your tool and you can explore. Okay. So if you are, be careful in this particular type of questions. If you are, yes, yes, we will come to that particular case. Okay, 1 minute. First, we will go step by step. Okay, yeah. So if you are using your inter assignment delay, whether it may be blocking assignment or whether it may be non-blocking assignment, your delay is going to get add. Okay, and every statement is going to get blocked, whether it may be blocking assignment or non-blocking assignment. If you are using an inter assignment delay, so is it clear up to here? Yes, everyone, is it clear? Yes. Now, now let us see intra-assignment delay example. Within an initial begin. Same example we will take. A is equal to 0, B is equal to hash phi 1, C is equal to hash 10 2, and D is equal to hash 15 3. D is equal to hash 15 3. And now tell me, after how many time units my C will be equal to 2? Once see the execution, A is equal to 0, B is equal to hash phi 1, C is equal to hash 10 2, D is equal to hash 15 3. I am using my intra assignment delay and I am using a blocking assignment. I am using a blocking assignment. So now tell me, after how many time units my C will be equal to 2?
10.
12, sir. 15, 15, sir.
I'm asking about C.
15 nanosecond.
Yeah. Yes, correct. So after 15 time units, my C will be equal to 2. Why? See here, we are using a blocking assignment. So coming to this A is equal to 0, this will happen at T is equal to 0 time units because there is no delay involved here. Coming to the second assignment, if you observe carefully, we are using a intra-assignment delay. That is, the RHS value will be updated to the LHS side after 5 time units. That is, up to 5 time units, my assignment is not yet completed. So up to 5 time units, my assignment is not yet completed. So since we are using a blocking assignment, it is not going to allow the compiler to go to the next step. That is C is equal to hash 10 2. So up to 5 time units, my compiler will wait at the second step only. So after 5 time units, it will come to the second step, that is C is equal to hash 10 2. Then after 10 time units, my RHS side will be equal to my RHS value will be updated to the LHS side. That is after 15 time units, my C will get the value of 2. So since we are using a blocking assignment, this blocking assignment will wait for the completion of whole execution. So this completion of whole execution will not be happening up to 5 time units. So after 5 time units only, my updation will be happening, so that after updation my assignment is completed, so it is going to the next step. So after 15 time units, my value of C will be equal to 2, and after 30 time units, my value of D will be equal to 3. So is it clear? Is it clear for everyone?
Yes, sir.
Others, is it clear?
Yes, sir. Sir, what will happen if we have non-blocking and all here?
Yes, yes. We will go case by case. Next case is that only. Okay. Yeah. Others, is it clear? Please respond. Yes. Now let us take the case of non-blocking. Initial, begin, A, non-blocking of 0, and B, non-blocking of hash phi 1, C, non-blocking of hash 10 2, and D, hash 15 3. End. Now tell me, after how many time units my C will be equal to 2? After
10
how many time
nanosecond.
units? Yes. After how many time units my C will be equal to 2? Okay. Yeah, please text in the chat. Okay, only two responses. After how many time units? Once see the question again. A non-blocking of 0, B non-blocking of 1, C non-blocking of 2, D non-blocking of 3. Okay, I am using intra-assignment delay. I am using my intra-assignment delay. So after how many time units, my C will be equal to 2. All of you got the question right? 1, 2, 3, 4. Others, please respond. Yes. So after t is equal to 10 nanosecond, my C will be equal to 2. Because since I am using a non-blocking assignment, here at t is equal to 0 only my assignment, first assignment is happening. Next, coming to this particular assignment, up to t is equal to 5 time units, my value 1 will not be updated on the LHS side. Okay, that is true. But this non-blocking assignment is not going to wait for the completion of execution. It is going to the next step. The compiler is going to the next step. And here also, it is not going to complete the execution. Okay, so the compiler is not going to wait for the completion of execution. So everything is going to run parallelly in this case of intra-assignment delay. If we are using this particular intra-assignment delay, everything is going to run parallelly, and a value will be updated at time t is equal to 0, and b value will be updated at time t is equal to 5, and c value will be updated at time t is equal to 10, and d value will be updated at time t is equal to 15 time units. So this is what it is going to happen in the case of intra-assignment delays with non-blocking assignments. Is it clear? Is it clear for everyone? Total time in execution will be 15. Yes, 15 time units. Yes, correct. Okay. Yeah. Now, let us take one more scenario with intra-assignment delays. Initial, begin, a equal to 0, b equal to hash 5 1, c is equal to hash 10 2, d equal to hash 3 4, e is equal to hash 5 6. Now tell me, after how many time units my e will be equal to 6? So after how many time units my e will be updated to 6?
Sir, show me the question.
A non-blocking of 0, B non-blocking of hash 5 1, C blocking of hash 10 2, D.
15,
Please
15
mute your
nanoseconds.
mic. There is lot of disturbance.
15, sir.
Yeah, yeah. Uh, D non-blocking of hash 3 4, E non-blocking of hash 5 6. Yeah. So after how many time units my value of E will be updated to 6? Okay, 1, 2, 3, 4, 5. Only few responses. Please post your answer in the chat. Others try to answer. Yeah. So what is going to happen here? This is going to execute at time t is equal to 0, and we are using a non-blocking, so it is not going to block. And the updation is happening at t is equal to 5, and since we are using a non-blocking, it is not going to block. So at time t is equal to 0, we will get to this particular point, c is equal to blocking, c blocking hash 10 2. So this particular execution, this particular assignment to complete, it will take t is equal to 10 time units it will take to complete this particular execution. So up to time t is equal to 10 time units, this particular assignment is going to block further executions. So up to 10 time units it will wait, and after t is equal to 15 time units, t is equal to 15 time units, my e value will be equal to 6, and after t is equal to 13 time units, my d value will be equal to 4. So this is what it is going to happen. Is it clear for everyone?
Yes, sir.
Yeah.
One doubt.
Yes.
So as you told, like intra delay is like assignment, no? Like
Yes.
storing the right side value to left side variable. Then
Yes.
how can we consider into delay that one? Like
Pardon?
execution will happen at t equals to 0 only, no?
No, no, no. Execution started at t is equal to 0, but the updation is taking 10 time units to update. So for
Yeah.
yeah, since we are using this particular blocking, so C is waiting for 10 time units to get the value of 2. So this is also a delay, right? It is also waiting for 10 time units to get this value 2. Okay.
But like further variables are not dependent on zero. Like why should other variables should wait for zero?
This is
Like
blocking.
okay, okay.
This is blocking. If we use non-blocking, other variables will not depend. But here, since we are using blocking, so until the completion of this particular execution, we will not get the value of others. Okay.
Okay.
Yeah. So is it clear for everyone? Others? Now, let's say if we have declared reg a comma b, and within an initial begin block, if we have written hash phi a is equal to 0, okay, and another initial block, let's say hash phi b is equal to, sorry, b is equal to hash phi 0. Okay, now tell me, after how many time units my a value will be equal to 0, and after how many time units my b value will be equal to 0? After how many time units my a value will be equal to 0, and after how many time units my b value will be equal to 0? Yes. So did you get the point? So if you use inter-assignment delay or intra-assignment delay, the updation of value is taking the same time units, t is equal to 5 and t is equal to 5. But you are going to get the difference between the inter and intra-assignment delay if you consider this particular type of example. Is it clear for everyone? Others, is it clear? Yes. No. So this was about your blocking assignments and non-blocking assignments with inter-assignment delay and intra-assignment delays. So is this concept clear? Is it clear for everyone? Is there any doubt up to here? Yes. Can we move forward? Yes. Yes. Now, so we have some system tasks. Now we will discuss. So anything starting with dollar symbol, it is a system task. So we have several system tasks. We will discuss one by one. So first one is dollar display, which is a normal display which executes its parameters whenever it is present in the code. So basically, it is used to display the variables, or if we want to display any messages or something, we use this particular dollar display. And coming to the syntax, we have dollar display. We can use any message. Let's say suppose value of a is percentage b. I will write it again. Dollar display value of a is percentage b comma a. Here percentage b is called my format specifier. It is known as my format specifier. That is in which format I want to present my value. That is, it should be in binary, or whether it should be in decimal, or whether it is a string value. Okay, so for everything we have some format specifiers. I think it is included in this ppt only. Yeah, so these are my format specifiers. For printing a decimal number, you are going to use a format specifier which is known as percentage d, and for binary it is percentage b, hexadecimal percentage h, percentage O is for octal, and for percentage C is for ASCII character, percentage S is for my strings. So if you want to display any particular variable, you can choose the format specified according to your requirement, and you can display your variables. So is it clear regarding the dollar display? Is it clear? We will come back to
Yes.
this. Yes, we will come back to this actual meaning of task. We will discuss it when we are discussing about functions and tasks. Okay. So task is nothing but a repetitive code, or it is what to say. It is a it is basically a routine. It is basically a routine which is going to return some particular. It is going to perform any particular operation. Okay. So in detail we will discuss when we are discussing about functions and tasks. Okay. So basically, dollar display is already a predefined task. It is a system task, which is already the code for that is particularly written in the libraries. Okay, is it okay?
Yes, sir.
Yeah. Now coming to this dollar write, so it is similar to dollar display, except the dollar display displays the contents in the next line, unlike the dollar write in which the contents are displayed in the same line. So when we use this dollar display, the cursor moves to the next line, whereas if we use dollar write, everything will be printed on the same line. So we will see one example. I have one example with this. So after completing the event scheduler, we will discuss this dollar write with some coding example. Okay, yeah. Next, coming to this dollar show, it executes only once in a time instant, and when all processes in the time instant have executed. So particularly this dollar show is executed at the end of that particular time instance. Okay, let's say suppose if we have a is equal to 0, b is equal to 0. Uh, let's say hash 5 hash 5. Okay, so let's say if we have used dollar show. So if we use this particular dollar shop here, it is going to execute at the end of this particular time unit. So you can use this dollar shop here also. So this particular dollar show is going to execute at it at only once. It is only going to execute at once, and it is only going to execute after everything has been completed. Okay. Unlike the dollar display, it is going to dollar show is going to execute at the end. Okay. So in the event scheduler, we will see this dollar show also. So is it clear? The dollar show and dollar display, is it clear? So you will get more clarity when we will see
Yes, sir.
some particular example. I have some examples here. Okay. Coming to this dollar monitor, it will continuously monitor. As the name suggests, it is going to continuously monitor if there is any change in the arguments or not. So if we write dollar monitor a comma b, so this dollar monitor is going to continuously monitor if there is any change in the values of a and b. So if there is any change in the value of a or b, this particular dollar monitor is going to execute. Unlike the dollar display and dollar show, which is only going to execute only once, this dollar monitor will execute whenever there is any change in a, or whether there is any change in b, or both. Okay, is it clear?
Yes, sir.
So this example, we will come back. First, we will see the event scheduler, and we will come back to that particular example. Okay. Now, so let's say if we have initial begin a is equal to 0, b is equal to 0, hash 5 a is equal to 1, b is equal to 1. Okay. Now, at what time unit or time step this particular a is equal to 0 and b is equal to 0 is happening?
0, sir.
0. So at time t is equal to 0, my a is equal to 0 and b is equal to 0 is happening. So for every time unit or every time step, there is a particular event that is going to happen. So that is nothing but our Verilog event scheduler. Now we will see. So for every time step, we have this particular events that is going to happen. So here, let's say if we are in time t is equal to 0, if we are in time t is equal to 0, then our compiler is going to first execute the active event, then it is going to execute the inactive events. So we should not use this inactive event, that's why it's a cross mark here. and it is going to execute this NBA event followed by the postpone event. After completing all the events present in this time t is equal to 0, then only it is going to next time unit, that is in our example it is time t is equal to 5. And in this time t is equal to 5, again we have this four events: active, inactive, NBA and postpone. So for every time slot we have declared in our code, for every time slot we have this particular events. So is it clear? Is it clear for everyone? Yes. Now let's see what are the events which are present in this particular Verilog. So we have four events which are present in Verilog. First is active, next is inactive, followed by NBA. NBA stands for non-blocking assignment. NBA stands for non-blocking assignment, and followed by postpone region. Now, in the case of active region, if you observe carefully, here they are written. So, in the case of active regions, we have blocking assignments, evaluation of RHS of NBAs, continuous assignments, dollar display command, evaluation of inputs and update the outputs of primitives. Primitives, any idea? We have discussed it, right? What are meant by primitives?
Method methods.
Yes, all the gate level modeling we have seen, right? Primitives, AND gate, on OR gate, all those are our primitives. So evaluation of inputs and updation of outputs of primitives. So all these particular tasks are going to happen in our active regions. So in the active region, our blocking assignments are going to execute. Our wait a minute. So in our active region, what and all we are going to happen? Dollar display statements are going to execute, blocking assignments are going to execute, primitive continuous assignments that we will see in our data flow modeling. Okay, and what else we have? Primitives it is going to execute. And one more important thing, evaluation of
Non-blocking.
RHS is going to happen. Evaluation of RHS of non-blocking assignments, this and all it is going to happen in the case of active region. Blocking assignments, evaluation of RHS of NBS, only evaluation, not the assignment. Okay, and continuous assignments, dollar display command, evaluation of inputs and updation of outputs. Here updation is happening, but here in the case evaluation is only happening in the case of NBS, in the case of active region. Is it clear? Is it clear for everyone?
Yes, sir.
Yeah. Others, is it clear?
Sir, continuous assignments we haven't discussed yet, right?
Yeah, that's what I said, right? So continuous assignments we will discuss in data flow modeling. Okay, is it clear? Yes. Now, so one question. So what happens if I write initial begin a non-blocking of 0, dollar display a is percentage d comma a. So what will be my display statement will be printing? So what is the display statement is going to print?
A is equals to 0, sir.
Okay. Okay. So I'm using reg A. This is obvious, right? We should use only reg. Hmm. Now tell me,
A
what
is
my
0.
okay. Others, please try to answer, and you can also refer this diagram.
Show me the question once.
A000. Okay. Others, please try to answer. Initial begin a non-blocking of 0, dollar display a is
Unknown.
percentage d comma a.
Unknown.
Yes.
Why? Because the RHS side will be evaluated at active region, but it will assign into the non-blocking region.
Yes.
So the dollar display will be work on the active region only. It does not.
Yes. So yeah, I will explain it. So what is where is dollar display present? Here dollar display is present in the active region. Okay. So in the active region, dollar display is present. And coming to this non-blocking assignments, what I have said, evaluation of RHS is only going to happen, but not the updation. So here, in the case of active region, only evaluation is taking place. Evaluation is taking place, but not the updation. That is, RHS side is not going to assign to LHS side in the case of active region. But where is my dollar display? It is in active region only. So what happens is dollar display cannot see the value of LHS side. So if I try to display this particular value, I will get A is equal to unknown. I will get the value of A is equal to unknown. Is it clear for everyone?
Yes,
Yes,
sir.
sir.
So shall I explain it once again? Is it clear? So this is a very very important point and very confusing point. Many times we will get confused. We will simply write a is equal to 0, but that is not going to happen because at the same time step t is equal to 0, t is equal to 0, dollar display is in still active region and my updation from the RHS side to LHS side is not yet happened. So my dollar display is going to still display a is equal to unknown. Okay, is it clear for everyone?
Yes, sir.
Yes. Now, so when is updation happening? It is going to update at NBA region. So at the NBA region, my LHS side of NBA will be updated. On the in the NBA region, that is non-blocking assignment region, my RHS will be assigned to the RHS will be assigned to the LHS. Now, if I want to display the value of A, then what can I do? I should only use the dollar display statement, but I need to display the value A. So what can I do? Any guess?
Sir, repeat once.
Yeah. So in this particular example, what I've shown on the screen, dollar display is equal to percentage d comma A. My A value is not getting displayed. I'm getting A is equal to unknown. So for printing my A value, what can I do? I should only use dollar display only, but I'm not getting A value. I'm getting unknown. So how to get my A value? What can I do?
I think delays.
Use blocking, change it to blocking. I should I should only use non-blocking only. Blocking, yeah. They are your
We can
students.
use inter delays.
No. So what can we do is we can introduce this dollar display statement in the next time unit. We can use hash fun. So what happens? So this at time t is equal to 0, my NBA region, in my NBA region, my A will be updated the value of 0. So at next time unit t is equal to 1, my dollar display statement is going to print the value which is previously stored in the A. So if I use hash 1, my A value will be equal to 0. Is it clear for everyone? So if I use hash 1, then what happens? My next time step will be started and again my fresh event will be started. So what happens? Dollar display statement, if we are using, it is going to print the previous values of A. Is it clear?
Yes, sir.
Yeah. Is it okay for everyone?
Yes, sir.
Yes. Okay. Is there any doubt? No, right? No.
No, sir.
So be careful if you are using dollar display with non-blocking assignments. This is what it is going to happen. Dollar display is going to display the previous values when you are using a non-blocking assignment. Okay. But if you are using a blocking assignment, A is equal to 0, dollar display. If you want to print the value of A, then what it is going to print? It is going to print the
Zero.
present value. Okay. Is it clear?
Yes, sir.
Yeah. And let's say within an initial begin block, if we have written dollar display, the value of a, and a is equal to 0. This is written inside an initial beginning block. Now what happens? What may be the value of a?
0 itself.
Others? Okay. Okay. So this is yeah. Everything you may take anything, percentage D, percentage B, anything you can take. Just a random example. My question is, use the dollar display before the assignment and check what is going to happen. Okay, so this is your small task. Okay, so with this we will end the session here and we will continue the rest in the next session. Okay, so I hope you have got a clear idea about what is meant by dollar display and brief explanation of this Verilog event scheduler and blocking and non-blocking assignments with inter and intra assignment delay. Okay, we will see, once try this. If you know how to use a simulator, if you know how to use a Vivado tool or any other tool, once use initial beginning block, and once use yeah once you use a simulator and try to answer. Okay, yeah, okay then. So if you're having any doubts or queries, you can ask me, or else we can end the session. Yes, someone has raised their hand.